So important to notice is that this if statement is executed sequentially. That is to say that it is executed line by line from the top. It evaluates the first condition, and if this condition is met, it will enter this statement: total wage equals hours, or total equals wage times hours 1. It will execute this, and then we'll skip the rest of these else if statements and go beyond the if else statement block. It assesses this first condition first, then it will assess this condition, and then last it'll assess else. It's very important to know. So we have some examples for you to try. I don't think I'm going to cover coding these. They're pretty simple, and the solutions are posted at the end of this presentation, and they're shown here real quickly. So the last topic we want to cover are the use of functions in MATLAB. So functions are a separate M file that you can call to do work. So MATLAB has a bunch of built-in functions. For example, cosine, sine, mean. We used a couple of them today: exponential, the log. So you can try a couple of these MATLAB functions. But just remember, just like in Excel functions, you give a function an input, and the input can be a scalar, a vector, or a matrice, and the function takes that input, does some work on it, and returns an output value, which can also be a scalar, a vector, or a matrix. So there are certain rules that you need to follow when creating a function file, and they are listed here. The first line of the function must start with function, okay? And then you need to tell MATLAB what the output variables of this function are going to be, equals the function name, and then after the function name, inside parentheses, the variables that you are expecting to input. This must be the first line of the function file. The next criteria: the body of the function must set the output variable. So in this previous example, the output variable is called output vars. So there must be a line within the body of the function that says output vars equals something. If this is not in your function, MATLAB will give you an error each time you try to run it. And then lastly, you must save this M file as the same name as the function name. In this example, the function name would be func_name. So you need to save this function file as func_name.m. And just like variables and M file types, don't put spaces in your name, and they must start with a letter. So here are some examples of writing a function and doing some work. I think I'm going to go over both these examples because functions seem to give students the most problems. So this first example, write a function that calculates this equation: y equals 3 times x plus 4 times z times w. Okay, so the inputs are x, z, and w, all scalars, and the output is y. So let's create a new M file, and we start with function. Our output variable is going to be y equals, and then we need to decide on a function name, so we'll call this functryit1. So that's the name of our function. And inside parentheses here, after the function name, we need to specify our input variables, which were x, z, and w, I believe. X, z, and w. Okay. So the first line is complete, and then all we need to do is set our output variable y equal to something, which is the equation 3x plus 4z, 3 times x plus 4 times z, and then all times w. So this is our simple function, functryit1. So we need to save this as functryit1.m, save as, and MATLAB already manually knows, functryit1.m, save. So then we can go back to our command window, and we can call our function, functryit1. And then we need to give 3 inputs. xzw. And MATLAB, even on the command window, just like in Excel, will pop up and tell you what it expects you to input. So xz in w. So we need to specify some numbers, so we'll say x is 4, z is 6, and w is 10. How about that? We'll see what the value is. 360. So we can just check 4 times 4 plus 3 times 6 all times 10 should be the same value. Oops, I must have done something wrong. 3 times 4 plus 4 times 6 all times 10. 360. Okay? And we can even go over to our command history, copy this command, paste it, and we can try a couple different values. 5, 9, 5, 9, and 100. Okay, and so the function will calculate a y value. So this is a good example of using a function to calculate some algebraic equation. And so you can calculate, or you can modify your function file to a specific function type without having to change the contents of, say, your M file that's calling this function. So this is example, we'll try it 1. And then the second example is write a function fact.m that calculates the factorial of a number n. So if you remember probably from calculus, the factorial of 5 is 5 times 4 times 3 times 2 times 1. So the inputs of this function is just the number that you want to take the factorial of, and the output is the result, the factorial of the number.
As seen
Okay,
here,
and we give you a hint, you need to
vector
use a
A
for loop.
can be declared using curly brackets.
So let's do this together. We'll create a new M file, function, and the return val we'll call return val equals fact, and then the input is n, the number of the factorial we want to take. So we save this as fact.m. Okay. So if we look at the PowerPoint here, we notice that there's kind of this discontinuity. If n equals 0, the factorial is 1, and then if n is greater than 0, we need to follow this formula here. So we need to think about how we're going to do this in an algorithm as the code executes line by line. So the first line we can try, and we can use an if statement. If n is equal to 0, then we'll say our return val should be 1. The factorial of 0 is 1. Else, otherwise, if n is not 0, we need to use a for loop for I equals 1 to n, and end, and end. Okay, so now we need to think about how we're going to set up this value. So what we'll do is we'll set return val equal to 1 initially, and then we'll say return val equals return val times I. So let's look at how this loop will execute. So if n is not 0, we'll come here and we'll say, okay, return val should start with 1. So for I 1 to n, so let's say that n is 5, return val equals return val. So this is a very common use. We use the value we're storing, return val, in its own equation to calculate itself. So return val, which equals 1 the first time. So for I 1 to n, I is 1 the first time, equals 1 times 1. So return val is then 1. We go back up. I is now 2. Return val was 1 times I, which is 2. So return val 1 times 2. So return val is now 2. Go back up to the for loop. I is now 3. Return val was 2 times I is 3. So return val would then be set to 6. and hopefully you can observe how this loop is performing the factorial calculation correctly. Okay, so it's just important to note that we can rewrite this value in return val, and we can use itself in its own calculation. It will use the old value of return val on the right side of the equal sign, and will store the new result in return val on the left hand side of the equal sign. So we can save this, and we can go back to the command window, and we'll clear, we'll CLC. So let's check factorial 5. 5 times 4 times 3 times 2 times 1 is 120. And then we can try and call our factorial function fact, and n is 5, and hopefully we get back 120. Okay, and then we can even calculate the factorial of any number we want. Fact of 100 is huge. So that's how you would set up a function file to calculate the factorial. And this example should help you in your homework. So lastly, there's an exercise to kind of combine if statements and loops, and then it even introduces a quick plot with this plot tq command, but we'll cover plots next week. And then the solution is on the next slide. So you can try and code this up and look at the example and try and learn how you would write a program to do this problem. And there's some additional notes. Popular function is length. Length returns the number of values in a vector. So you can use it at a for loop. So when you have a vector that you don't really know the length of, but you want to loop over, you can use this line for, and there should be an I equals 1 to 1 to the length of x. So if there's 51 values in x, length of x will return 51, and I will loop from 1 by 1 to 51. And then also, probably you guys have figured out, you don't need to specify the spacing inside. When you declare a vector with colons, you don't need to specify 1. It is the default value. So 1 colon 1 colon 10 will create a vector x equals 1 2 3 4 5 6 7 8 9 10. But you can also do the same thing, just 1 colon 10, and MATLAB uses its default spacing of 1. Okay, so please take some time and go over the examples. This was only an hour presentation, so in lab you should have an extra hour to do some work in MATLAB. Thank you.